Welcome back. In the previous video, we walked through the basics of setting it up. We talked about what bagging is, and basically is sampling with replacement. We set up our data, did some exploratory data analysis, some pre-processing, and fit the actual decision tree model, and also prepared the scoring for our model, both within training as well as in the test data itself. The importance of that really cannot be stressed enough. That is that we want to actually get an average score rather than trusting on 1 point estimates. So what we did is actually a tenfold cross-validation. So let's just proceed now to look at bagging. So we're going to look at bagging, and one of the thing about bagging is that it has within it built-in a setting called OOB, which is out of the bag score. Now we're going to set that as false, and I'll explain that in a minute. So to begin with, we're going to set this up as bagging. The classifier is equal to the bagging. We already imported this. So the best estimator, okay, the base estimator is actually the the decision tree that we used earlier. So this CLF that we use. Remember what bagging is. The bagging is actually an ensemble model. And so in this case, what we are doing in here is that we're actually doing a bootstrap sampling replacement, and bagging is actually on top of the so-called base classifier that we use. In this case, we are using the base classifier as the decision tree model. Right, we're going to run quite a fair few estimators, 1,000 in fact. And the other thing is that we're going to do bootstrap. Set the bootstrap to true, and jobs is equal to -1, meaning we're going to use up all of our calls, and the random state is equal to 42. Okay, now that we have instantiated that, we're going to fit our model, X train and Y train. Okay, right, what do we see here? Our base estimator here, as I mentioned before, is the decision tree. We didn't actually specify the class weight, the class weight being the target that we're looking at. In fact, it is a good idea to actually specify our class weight, but for now, I'm going to leave that out to see if the bagging can actually work around that. There are other things that we could specify, but we left them all out. Okay, the bootstrap is true, so since we're actually doing random sampling or sampling with replacement, and the number estimator is 1,000, use all the cores available on this machine. For now, what we are setting is this OOB underscore score is equal to false. Let me just point you to the documentation in scikit-learn. When the OOB is set to true, what this is actually doing is that when you are doing bootstrap sampling, you are not using all the data. You are only using a subset of that. So that means we actually have some data left over. What are you doing with the leftover? That's when you use it as a test. Of course, all of these are set aside as still the training data. But because you only are using a portion of the training data, not the whole lot, the leftover is being used as a test data. Test within the training data, I mean. So with that, you can actually work out the so-called out-of-bag score, which is you can actually get the generalization accuracy, okay, or generalized accuracy. So let's look at our score, which we actually set up earlier. So the print score that we set up, and the classifier that we already now this should be bag classifier, and we're going to provide the X train and the Y train, X test, and also the Y test. Okay, so X train, Y train, X test, Y test. So just triple checking X train, Y train, X test, Y test, and also the CLF. With this, we set our train is equal to true. We are still running within the training score. Okay, it may take a wee while to run. All right. Okay, so we are still waiting for the score to come through. We have the accuracy score, we have the classification, then we have the confusion matrix. The last thing we want is the actual this score here, which is the tenfold cross validation. So depending on your machine, it might take a wee while. Okay, finally has come through 7879, and 7879 is actually an improvement over the decision tree itself, 78. The accuracy standard deviation, it's about the same. Yeah, slightly lower, but in terms of the accuracy score, it has improved marginally. Now notice and also remember that we have not done grid search yet, so far so good. At least there is an improvement. So let's have a look at the out of sample test score. Okay, let's wait for a while. Okay, the accuracy score is 7455, so that's actually a dropped. Now, it's always challenging, the reason being that we have such a small training data set. We only have 180. It may have an impact on the result itself. Okay, so right, what we're going to do next is have a look at the bagging score. Right, bagging, except that this time we're going to run it as the out of the bag score is true. Okay, so we're basically using the out of the bag. Let me just type this out. Use out of bag samples. Within bag are those that we've used to train. So there's some left over. So we use those to estimate the generalization accuracy. Okay, let's have a look. Okay, so again we use our bag CLF. Let's go to bagging classifier, and the base estimator is still the same. It's the CLF. The number estimator, we can actually put up higher, but that will take longer to run for now. You can actually increase it to 5,000 or 10,000 if you're willing to wait. I don't think you'll be willing to wait watching me, so I'm gonna make it easier, so you can always do that at your own time. And use up all the calls, number of jobs, let's go to -1, and finally the random state, set that to 42. Okay, right, bag underscore CLF and fit the X train and also the Y train. Okay, now that it's fitted, let's have a look at the classifier score. Okay, the out of the bag score basically said that it should be around 81% accuracy, which is interesting. We weren't able to actually get that. So let's just print the score. So again, this time around, I'm gonna be too lazy to type, so I'm just gonna copy this whole thing. And let's just run that. And while that is running, I'm just gonna get this prepared and have it ready to run. Okay, so all of the bag scores say it should be around 81 or 82%. Let's look at our... Now, that is basically telling me what the score should be for the test data. Let's have a look. We're waiting for, right now we're waiting for the average accuracy for the tenfold cross validation. It comes out at 78. It seems that the tenfold gives a better accurate score. Now don't read too much into that. I think when we actually do our next exercise, which has a much larger data sets, let's assess it with that, because right now when you look at this, there's only 55 data points here. With that, I'm gonna end this portion. So for now, what I'd like you to do as an exercise is, you guessed it, what I mentioned before is, let's come over here to the portion that I want you to actually look at. I'd like you to actually change your estimators. Try on 5,000, and you might want to specify some of these maximum leaves. Take a moment and try that to see if you can actually get a better or an improvement, so especially with the estimators. Try it with 5,000 with the all of the bag score. I should really actually make this a score. Okay, what is it actually? So it's small caps. All of the bag scores score. Okay, set it as false, and OOB score, set it as true. Run it with 5,000 again and see what it looks like. So pause the video. When you come back, I'm going to wrap up the lesson. How did that go? I hope you tried that and give it a go. It took a bit longer to run, of course. But at the very least, I think the accuracy score should actually improve somewhat. It's in essence what we've covered in this lesson is the decision tree itself. However, right now we actually have applied debagging. All right. Remember, the debagging is bootstrap sampling or sampling with replacement. Having done that, both with the OOB score as false as well as the OOB score as true. The OOB score allows a generalization in terms of the accuracy of our estimator. In this case, is the ensemble of bagging of the decision tree. With that, I'm going to stop this lesson, and the next lesson we're going to start looking at another really exciting ensemble method, which is called random forest. I look forward to seeing you in the next lesson.